Let's talk about rearranging formulas. Didn't mean to draw that. Rearranging formulas. There are many formulas in math and science that give us the relation between different quantities. We can use formula to determine an unknown quantity. To do this, we have to rearrange the formula to solve for the unknown. Basically what that means is we might have to move things around in order to determine and to solve for something that we don't know. In geometry, the exterior angle of a triangle is equal to the sum of the interior angles at the other two vertices. So in this case is D is equal to A plus B. Rearrange the formula to express A in terms of B and D. So the formula they give us is D is equal to A plus B. I want A to be alone, so how do I rearrange this formula in order to have A isolated? Well, I simply take B and I subtract it from both sides, and I end up getting D minus B is equal to A. The circumference of a circle in terms of its radius is given by the formula circumference, or C, is equal to 2 pi r. Rearrange the formula to isolate for r. So 2 pi r basically means that 2 multiplied by pi multiplied by r is equal to the circumference. So 2 times pi, we can divide that 2 times pi. So 2 pi essentially cancels out. So this goes away, that goes away. But what I do to one side, I do to the other. So then I have the circumference divided by 2 pi is equal to our r value. The area of a square is related to its side length, L, by the formula area, or A, equals L squared. Find the length to the nearest tenth of a centimeter of a side of a square with the area of 32 centimeters squared. So I have my formula, area equals L squared. They give me my area, so that's 32 is equal to L squared. Now, we know from previous lessons that the opposite operation, or in order to isolate L, we need to perform the opposite operation. So the opposite operation of squaring is square rooting. So by square rooting L, we must square root the left side as well, so the square root of 32. In this case, it ends up being about 5.7 units, or centimeters in this case, is equal to a length. Second example, the equation of a line relates y to x, m and b. Or what I've highlighted here, the equation of a line is y is equal to mx plus b. Rearrange this equation to express x in terms of y, b, and m. So expressing x basically means get it by itself. So the equation we have is y equals mx plus b. I want x alone. Well, my first step, I got to get rid of this addition of b, or positive b. So how do I do that? Well, I bring it over and it becomes negative. So y minus b is equal to mx. Now, I have to divide both sides by m to isolate for my variable x. So then on the left side, I have y minus b divided by m is equal to x. If I want to go one step further, this is also y divided by m minus b divided by m is equal to x. This will make more sense as we get into our linear relations unit. Last example, the force of gravity between two objects is modeled by this equation here. F is equal to gm1 m2 divided by r squared, where g is the gravitational constant, m1 and m2 are the masses of the objects, and r is the radius. Rearrange the formula to solve for the radius. So I'm looking for r, just singular r. So my equation here, first thing I got to do, it's being divided by r squared. Well, if I multiply this side by r squared, I'm just going to write that in. If I multiply this side by r squared, I have to do it to the other side too, right? R squared. So now I have r squared times f is equal to gm1 m2. So I got rid of that fraction. Now r squared is being multiplied by f. So I divide both sides by f. Divide by f, divide by f. So I'm left with r squared is equal to gm1 m2 divided by f. Well, I'm not quite done because I'm looking for r by itself. This tells me that this is the r value squared. So the opposite operation of squaring is square rooting. So I need to square root this in order for me to isolate the variable r. And when I do that, I have to do it to the right side as well. So the formula rearranged to solve for the radius is the square root of gm1 m2 divided by f.